Okay, you guys, so today's video is going to be like the previous video where I'm basically just sort of walking you through examples. So you need to take notes as you watch the video, okay? So you can pause it, write down what I'm writing, anything like that. After we're done with vectors, we will go back to doing where I have a video and I post actual notes for you. But for these vectors, we're just doing it completely lecture style. All right, you guys? Sorry if that's inconvenient to you, but it's just how it's going this time, okay? So today we're talking about adding and subtracting vectors. So for instance, let's say we had two vectors, and let's say we were walking, and we walked north for 5 meters, okay? Then after we walked north for 5 meters, we turned and we walked east for 3 meters, okay? This is going to be vector A, and this is going to be vector B. What we want to find is vector C, which is going to be equal to vector A plus vector B. Okay, so what it wants from us now is that we want to find this vector. Now, you'll notice if we traveled 5 meters and then 3 meters, 5 plus 3 would sort of be our distance, right? However, if we started here and ended here, this C vector would be our displacement. So, how we add vectors A plus vector B is we're going to actually add their x and y components. So, vector A's x component is actually 0 meters. You'll see it goes nowhere in the x direction, but its y component is 5 meters. And then for vector B, its x component is 3 meters, and its y component is 0 meters. So in order to find vector C, to find the magnitude of it, we're going to want to find its x and y components. So its x component, C sub x, is going to be 3 meters plus 0 meters, which is going to be equal to 3 meters. And its y component is going to be 0 meters plus 5 meters. And that's going to give us our y component. So all we did was we added together the components of the vector. Now that we have its x and y components, we can solve for what this actual magnitude is. And since this is a right triangle, we can use the Pythagorean theorem. So remember that the Pythagorean theorem is c squared equals a squared plus b squared. So to get c by itself, we want to take the square root. So to find the magnitude of vector c, we're going to do the square root of 3 squared plus 5 squared. So we're going to do c equals the square root of 3 squared plus 5 squared. And that's going to give us that the magnitude of c is equal to 5.83 meters. So that's our magnitude of vector c. Now, all we would need to do is find the direction of vector c. So in order to do that, we are going to look at this as if it were on the xy plane, okay? So this would be our x and this would be our y. Now, we already know what the x and y components of this are, and if we're solving for theta, that means we can do what we did previously, where we said that the tangent of theta is equal to the opposite, which would be the y, which we know is 5 meters, over the adjacent, which would be the x, which is 3 meters. So that means in order to find our angle, we would do theta equals the inverse tangent of 5 over 3. Okay? And when we do that, we get that theta is equal to 59.04 degrees, and that's going to be north of east. Which means our overall vector C is going to be equal to 5.83 meters, 59.04 degrees north of east. So we just found vector C by adding vectors A and B. So let's look at another example together to try and get a better hang of this. Let's imagine that we have a XY plane and it has all of these vectors on it, okay? Okay, let's say we have all 4 of these vectors are given to us. Now, we're asked to add them together. However, these aren't connected, are they? Well, they don't necessarily have to be connected in order for us to figure out what, let's say again, the net displacement would be of all of them, all right? So let's act like we wanted to add together A plus B plus C. Well, what we would have to do is break them all up into their X and Y components. So let's start with B and C because they're going to be pretty easy. B is going to have an X component of 10 and a Y component of 0 because it is right on that X axis. C is going to have an X component of 0 and a Y component of 25. But it's actually going to be negative 25 because it is going down, and direction super matters in vectors, okay? But now we need to look at A, and we need to break it up into components like we have learned. So if we want the X component of A, we know that it is adjacent, correct, to this angle. So we know that the cosine of that angle, 60, is equal to the adjacent over its hypotenuse of 15. So if we do 15 times cosine of 60, we will get that x is equal to 7.5. Then we need to find y. Well, the y side would be opposite of this angle 60. So we're going to know that the sine of 60 is equal to y, which is the opposite, over the hypotenuse, that's 15. So if we do 15 times sine of 60, we'll get that the y component is 12.99. So we just found the x and y components. Now what we were asked to do was find A plus B plus C. That means we need to add together, to start with, all of those x and all of those y components. So let's deal with x first. If we deal with x first, we have that the x of A is 7.5, the x of B is 10, and the x of C is 0. So we're going to have 7.5 plus 10 plus 0, which is going to give us an x component of 17.5. Now we have to think about the y component. We know that the y of A is 12.99, the y of B is 0, and the y of C is negative 25. So we're going to have 12.99 plus 0 minus 25. And that's going to give us negative 12.01. So we know that this vector, the displacement vector, A plus B plus C, would occur at 17.5x, negative 12.01y. But what we want is we want to know the actual magnitude of the vector that occurs at this place. So remember, if we're given the x and y components, that's basically our A and B of the triangle, and we can use that to solve for the hypotenuse. So we know that the hypotenuse is equal to the square root of a squared plus b squared, this being our A and B. So we're going to take the square root of 17.5 squared plus negative 12.01 squared. And that's going to give us that our overall magnitude of this vector is 21.22. Now, the only thing that we have left to figure out is the angle of it, okay? So, with these two, we can do, once again, that inverse tangent like we did previously. So, the inverse tangent of the opposite over the adjacent. Well, looking at this, you might be confused as to which one would be the opposite and which one would be the adjacent. So, how about we actually draw out this vector? So, if it has an x of 17.5, it'll be over here somewhere, and its y is negative 12.01. So, it would be about over here. So, this is what we're looking at as our vector, okay? We want this angle right here. That's the theta we're looking for. So the opposite is the y, and the adjacent is going to be the x. So if we take the opposite of the y, it's going to be 12.01, because we always use the absolute value of these numbers when we're finding the angle, divided by 17.5. That's going to tell us that our theta for this vector is 34.46 degrees, and that's south of east. Which means that this would be equal to 21.22 at 34.46 degrees south of east. And we just added together 3 whole vectors. Okay? Now, other than adding vectors, you can actually subtract vectors too. So, let's see what happens when we do vector A minus vector C. All right? So, we're looking at A minus C. Okay, just now we actually got the x and y components of vector A, if you remember correctly. X was 7.5 and y was 12.99. And we said that for C, x was 0 and y was negative 25. So if we're doing A minus C, we're going to have that our x components are going to be 7.5 minus the x component of C, which is 0, which will give us an x component of 7.5. And then for y, we're going to do our y component of A, which is 12.99, minus our y component of C, which is negative 25. So we're going to have 12.99 minus negative 25. And that is going to give us a y component of 37.99. Now that we have the x component and we have the y component, we can find what the magnitude of this vector is going to be. So once again, we're going to do the square root of 7.5 squared plus 37.99 squared. That is going to give us an overall magnitude of 38.7. Okay, so our magnitude will be 38.7, but we're not done. We still need to find the angle or the direction for this vector. So let's switch it up a little bit because we don't always have to use tangent. So let's look at this and think about what it would look like on the graph, okay? Now we have positive 7.5 and positive 37.99. So we're going to be up here somewhere, okay? That means that if we're looking for this angle, let's say we want to use cosine, okay? Well, if we decide to use cosine, cosine of theta is equal to the adjacent over the hypotenuse. So the adjacent is going to be our x component, which is 7.5, and then the hypotenuse is our magnitude that we just solved for of 38.7, which means that theta is equal to the inverse cosine of 7.5 divided by 38.7. Now, when we do that, we get that our angle is 78.8 degrees, and we can tell from this that that's going to be north of east. Okay, so that's how we would subtract vectors. Now, I'm going to leave you with one to try on your own before you come to class tomorrow, okay? So, vector A has a magnitude of 40 meters and points in a direction 20 degrees below the positive x-axis. A second vector, B, has a magnitude of 75 meters and points in a direction 50 degrees above the positive x-axis. Sketch the vectors A, B, and their displacement vector of C equals A plus B, and tell me what the magnitude and direction of C are, okay? That's what we'll start with in class tomorrow. Try it out on your own first. I hope you all have a great day, and I will leave you with a picture of what vectors A and B would look like. Okay, here's what vector A and vector B would look like on a graph, okay? Now remember, when you're solving for C, you're going to want to be doing it from where you start to where you end. Remember, you need to solve for the x components and the y components, and then add them together. Do the Pythagorean theorem to find the magnitude of the vector, and then use either sine, cosine, or tangent to find the angle of that vector. I look forward to seeing you guys tomorrow and working this through with you.